The title of this video is Proving the Pythagorean Theorem. First, let's do a little review. The hypotenuse, always labeled C, is always the longest side of a triangle. The other sides of the triangle A and B, they're interchangeable in terms of labeling. And think about it this way. The Pythagorean theorem a squared plus b squared equals c squared that you're familiar with, since you're going to be adding the a squared and the b squared, the commutative property of addition allows those to be interchangeable. So it doesn't matter which of the other sides of the triangle are labeled A or B. Obviously you can tell when you see the lengths of the sides, which one is the longest side, which one would be the shorter side, normally the base, and then the other side. So you'd usually be able to tell. The Pythagorean theorem states that the sum of the areas of the two squares of the legs a plus b of a triangle is equal to the area of the square on the hypotenuse. Look at the graphic below. When they talk about the square, it's the square that's formed off of each of the legs. So here we have a triangle with sides 12 units, 13 units, and 5 units. So the square for the one side is going to be 12 units by 12 units square, and the area is 144 square units. And on the shortest side, the square is going to be a 5 by 5 unit square with an area of 25 units. So if we look at the hypotenuse, which would have to be 13 by 13 square, well, we can take the first square, the A side, and that's 12 by 12. And now we have to add it to the smaller square, the 5 by 5, which is 25 square units. Well, what you see that we've done here is we've just broken up the 5 by 5 square into the smaller squares, the actual unit squares, and there would be obviously 25 of those. And so what you can see is that we've taken 5 of those little unit squares here. Here's 5 more. That's 10. You know there's going to be 25 little unit squares because that's the area of the smaller square. So we have 10. Here's 15. Here's 20. And then here's the 5 that makes 25. And so now we have a 13 by 13 square on the hypotenuse. And if you were to count up each of those little unit squares in that 13 by 13, you would see that they total 169, which is 13 times 13. So we have shown that the area of the squares, the areas of the squares on both sides of the triangle are equal to, the sum of those squares are equal to the square that is along the hypotenuse. The Pythagorean theorem only works with right triangles. Hence the converse of it states, if the sum of the squares of both sides of a triangle are equal to the square of the hypotenuse, the triangle is a right triangle. So here we have what we're familiar with. A squared plus b squared equals c squared. So going back to our original triangle, 12 squared plus 5 squared should equal 13 squared. 12 squared, the area of that square that is along that side, is 144. And on the base, 5 times 5 is 25. That is the area of the square that's along the base. And 169 does equal 169, which is the hypotenuse squared. Based on what we have learned, let's try this. Suppose you're given the sides of a triangle. Can you determine if it's a right triangle? Well, you're going to use the Pythagorean Theorem. A squared plus b squared equals c squared. And you notice the first triangle, if a is 8, b is 7, and c is 12, when we do the mathematics, that is not a right triangle. It is a triangle, but it is not a right triangle. And triangle KLM, with sides of 3 for A, B equal 4, and the hypotenuse equal 5, 3, 4, 5 triangle, when we do the math, we see that 25 does equal 25 square units. So that one is a right triangle. Well, that ends this very brief video on proving the Pythagorean theorem and looking at its converse. So enjoy the activity. See what you can do.